Alright. My name is Joshua Brookley.
I'm Peter Schofield.
We decided to do a digital Etch-a-Sketch. So first, we decided our requirements should start with a graphical LCD display that starts up with a pixel in the middle of the screen,
and then using the buttons on the Nexus board, we were able to draw in all the different compass directions, up, down, left, right.
And then using the switches on the actual board, you can actually determine whether or not you want to draw like circles, or we have a preset image that you can put on the screen just to kind of test the capabilities of it.
And then to emulate the Etch-a-Sketch, we put an accelerometer so you can shake it and it would clear the display on it.
Oh. And this is our system architecture. Right here we have our block diagram. We've got a GPIO, SPI, and this is our hardware, which we'll go over in a minute, and our software that we'll go over in a minute. This is a block diagram. Alright, so in our hardware we actually have a timer counter which counts down for like a quarter of a second or so, and it counts down, and that actually controls the speed which we can draw in the different directions, and also sets the speed of the accelerometer to clear, so it doesn't clear like consistently. And then we use our buttons to control the different directions on that, and that's just connected through the GPIO. And our switches in the same respect, and those are used to either draw circles, draw the preset image, and also you use one switch to actually determine whether or not you want to clear, so it doesn't clear too much. And we have an analog to digital converter that we actually connect our accelerometer to, so that it converts the analog signal out of the accelerometer into a digital signal, so that we can read in properly. And the analog digital converter is connected through a SPI port, and the graphical LCD display, which is the key to the show, it is connected through a UART.
Alright. For the software, all these functions we put inside a while loop, our ISR, which drops, so it went off every quarter of a second. It would update the coordinates of where your current pixel is at, and if you press a button, it would update the coordinate, and that would happen on the interrupt. And then send the command to the LCD. We use the set pixel, start command, which tells the LCD you're about to get a command, and then set pixel, which means, okay, at this location, set the pixel to the opposite color of whatever the background of the LCD is. You can either have it all black or all white. And then a read Excel reads in from the ABC from the accelerometer. And then clear LCD is pretty self-explanatory. And a check status waits for the transmit field to be empty when sending data to our LCD screen.
We have things like we initialize the timer initially, like spin delay for other various functions, mostly for debugging and stuff. Alright, and so when we first started to actually get this working, our first goal was to actually just get the LCD display drawing the pixels initially. And we had a problem because we found out that our LCD display does not power off of 3.3 volts, so we had to get an external power supply. And you want to aim for like 6 or 7 volts, but the only power supply in this was 5 volts, so when we first started putting pixels on the screen, it would clear randomly because it would lose power. But after we got that up and running, we added buttons and switches to different directions by setting pixels at a time, but we still didn't have a clear, so then we decided to add the clear, so we started really simple and started building it up. So when we finally got the clear command, because originally we just had it so if you pressed 2 buttons together it would clear it, then yeah, we started adding a little more complexity by adding the analog digital.
And then we added the analog to digital converter. First we just put an input of 3.3 volts to see if we actually could read in from the using the SPI IP. And then we added the accelerometer to the ADC. The problem with that is that it outputs a really small voltage, so we found out it was about 50 millivolts, and we had to adjust our software accordingly. And then we added a preset picture, which is this array of XY coordinates.
And then after that, we just drew some fun pictures. So if you would like, we can demo it for you. Questions? Any questions? Comments? Concerns? Oh, Third.
Oh. Wait, actually, I'll ask you third.
Oh, okay. That works. Okay. So it's kind of it's a small display, so I don't know if everybody can see it, but
Sorry. Uh-oh.
yeah.
Unplug the monitor.
This is one.
That's power supply. Okay. This is.
Hopefully not
As long
our
as it's not
computer.
Have you already programmed your board?
No, we can do that now.
Well, I don't want to play with the computer anyway. Since
But you can unplug the monitor after we program it, though. That's what I saw.
it's cool.
Yep.
I
Around here.
don't know if that's probably the monitor. Just in case.
Alrighty. So,
It's probably really hard to see, but there's a pixel set on near the middle of it.
okay, and then
So-
you go ahead and you can draw lines. Let's see. Yeah, and then
The problem
draw
with counting
right,
with the LCD was it would draw a line on the side, and we just think that's a defect of the
actual
LCD.
screen. So, and then we can draw this lovely little picture. Yay,
A
look, a
little
little house.
house.
And we can draw a circle, draw Joe Stickman. We can draw down, up, or I can draw up because I accept the directions. He got sliced in half. And
do diagonals by doing
diagonals.
up and down at the same time.
And there we go. And there's Joe Stickman in front of his little house. And then to clear it,
Clear it, put the switch
You
on.
put the switch
I'm
up?
gonna erase it because it's already.
and
shaking.
there we go.
There
That's our.
That's awesome.